Hello, everybody. I hope you can all hear me. Welcome to this session on subtheme 4 of the IWRA online conference. My name is Dave Tickner, and my day job is working for WWF, based in the UK, focused internationally. My job title is Chief Advisor on Freshwater Issues at WWF. And I've been delighted and honoured to be invited to be part of the International Science Committee for this conference. I'll be moderating this session, and I'm joined by my co-moderator, Lesha Witmer, who will be marshalling the questions and answers for the session. Lesha will introduce herself shortly. There are a few things that I need to read out just to make you all aware at the start of the session. So first of all, the session is being recorded. The session will operate in English language. Apologies to those for whom English is not a first language. So that means if you do have questions, please submit them in English, and please submit them using the Q&A button, which should be at the bottom of your screen. Those of you who've been to this kind of conference before using Zoom, or perhaps been to earlier sessions in this conference, will be familiar with that. We will ask our speakers and panelists to address your questions as much as possible during the Q&A session, possibly after their talks, depending on how time is going. If we have a lot of questions, then we'll be asking people to provide written responses after the conference is finished, and those responses will be on the conference website. Please note that the chat box is going to be disabled during this session, but there may be a few useful messages that the conference conveners will share in the chat box, so just keep an eye open for it. And if you have any technical problems, please either go to the Zoom Help Center, which you can find via a Google search, or send an email to the conference organizers at IWRA. Their email address is online.conference@iwra.org, and they may be able to assist you. Okay, so I'm delighted that we're going to be joined, we're going to hear today from 4 speakers from the Philippines, Australia, and China. One of our speakers from Australia is actually speaking twice. So we, first of all, we'll hear from Diosa Marie Aguirre from the Philippines. Then I think we have Charles Essery from Australia, who will be the speaker who's speaking twice. So he'll speak second, and we'll also speak last. And his talks will sandwich talks from Yang and Wang from China. Hopefully that's all clear. And so I think without further hesitation, we'll move on to our first speaker, Diosa Marie Aguirre. So Diosa, over to you.
Hi, good day, everyone. So on behalf of my colleagues, Mr. Di Mayuga, Ms. Moreno, and Ms. Valenzuela, I'm here to present this undergraduate study entitled Removal Efficiency of Banana Pseudostem as Activated Carbon for Pre-Treated Laundry Wastewater Treatment. So next. So laundry wastewater carries lint, soil, dyes, finishing agents, and other chemicals from detergents. The significant parameters of laundry wastewater are BOD, COD, and the main component of laundry detergent, surfactants. So this study focused on treating laundry wastewater using banana pseudostem derived activated carbon, knowing that banana is one of the leading agricultural products in the Philippines, and the research used an agricultural waste, the banana stem. The research also aimed to determine the removal efficiency of activated carbon, the most effective cell setup. So next. For the objectives of the study, first is to determine the quality of raw laundry wastewater in terms of different parameters such as surfactants, COD, and BOD, and to determine the rate of effectiveness of banana pseudostem as activated carbon in treating laundry wastewater based on the standards of the Philippines DNR Administrative Order 2016-08 and in terms of the following parameters: surfactant, COD, and BOD. Next. For the significance of the study, this may help in reducing agricultural waste if proven effective, and laundry wastewater may have the potential to be reused or to be discharged with less pollutants. Next slide, please. The study began with the preparation of the activated carbon. Banana pseudostem was dried, powdered, and converted into activated carbon at Batangas State University Laboratory. Then, gathering a laundry wastewater sample from laundry shops in Batangas, Philippines, using grab sampling method was done. The samples were brought at the laboratory for the testing of the parameters needed, such as surfactant, COD, and BOD. Next slide. Then, improvised filter systems were made with a pre-treatment setup. For setup 1, there's 3 inches of activated carbon. For setup 2, 6 inches. And for setup 3, 9 inches of activated carbon. The collected water sample passed the sand and gravel filtration, and the effluent were collected and tested. Then, the water sample passed through the 3 setups, which consist of 3 different height of activated carbon, and they also have the sand and gravel on it. Next slide. For the findings, shown is the comparison of mean values of each setup with BOD, COD, and surfactants as parameters. Based on the analysis of an accredited laboratory, the initial values of untreated laundry wastewater in terms of BOD, COD, and surfactants are 10 milligrams per liter, 70, and 10.27 milligrams per liter, respectively. The untreated wastewater was filtered with sand and gravel as pretreatment, and values of percentage removal acquired in terms of BOD, COD, and surfactants were 0, 42.86, and 54.43, respectively. Next. Then shown is the comparison of removal efficiency of each setup. The percentage removal of the sand, gravel, and activated carbon filter was determined after analyzing the wastewater sample that passed through different variations of height of activated carbon, with highest removal of surfactants in setup 3 with 96.86% removal. Next. Thank you. So for the summary of findings, the values that developed from the first setup were on the first trial, the percent reduction of wastewater sample in terms of BOD, COD, and surfactants were 10%, 12.5%, and 19.01% respectively. And then for the average of the trials, for the BOD, it's 9.67 mg per liter, COD 35 milligrams per liter, and surfactants 3.87 milligrams per liter. Next. For the for the third setup. So for the third setup, the average for the BOD is 3 milligrams per liter, COD 11.67 milligrams per liter, and surfactants 146 milligrams per liter. So they are all in Class A parameter of the Dow 2016-08. Next. For the conclusions, the characteristics of the laundry wastewater in terms of BOD, COD, and surfactants were low, unlike the expected based from the related literature. The values were 10 milligrams per liter, 70 milligrams per liter, and 10.27 milligrams per liter. The third setup with the highest amount of activated carbon gave the highest percent of removal efficiency. The greater the amount of activated carbon, the more effective it is. And the mean values of the parameters for 3 trials after filtration in terms of BOD, COD, and surfactants were 3 mg per L, 11.67 mg per L, and 146 mg per L. And then the results of the study showed that the banana pseudostem activated carbon has been found to be effective media of filtration treatment for reducing especially the surfactants in laundry wastewater. Next. And as per the Philippine standards, the water quality of the laundry wastewater was Class C, which can be fishery water for the propagation and growth of fish and other aquatic resources, like boating and other similar activities for agriculture, irrigation, and livestock watering. The water quality of laundry wastewater after treatment was classified as Class A, which can be intended as sources of water supply. Due to the current scarcity of water supply, this was a huge advantage to both the laundry shop and the environment. So it might have a positive influence since it can be preserved. For the recommendations, the column cells that were used in the setup was rectangular. So for the recommendation, it should be circular because the difference is that circular column is more efficient than the cube column for the reason that when the wastewater passes through into the entire component, the wastewater passes through the circular column cells. On the other hand, in cube column, the wastewater was not able to pass through on the entire components of the cube column. So the setup should have sand and gravel filtration alone so that the percentage removal of it will be subtracted with the result of setup containing activated carbon to know the rate of the removal efficiency of the activated carbon alone. So that is all, and thank you very much for listening.
Diosa, thank you. That's a really interesting study. I do a lot of work, as I'm sure many people do, around the concept of nature-based solutions. And quite often nature-based solutions are approached at sort of quite a big scale to do with how we use landscapes. I think what you've highlighted there is that nature-based solutions can potentially operate at a much sort of more technical, smaller scale with use of substances like the banana pseudostem as a medium for water treatment. I'd like to reintroduce my co-moderator here, Lesha Witmer, who's an old friend and colleague. Lesha is the convener of Women for Water in her day job, although she wears many hats, I know. As I mentioned earlier, Lesha is going to be handling all the sort of question and answer sessions. So, Lesha, over to you. Any particular questions coming in for Diosa, or any questions you'd like to pose?
Well, first of all, thank you, Dave, and it's an extreme pleasure to work together again. We didn't do that enough in the last period. What I will try and do is like you said, summarize the questions that came in, and maybe at the end, because we're also looking to see if we can combine questions in some cases. But for our last and first speaker, there is a very specific question for you. If you like to explain what COD and BOD role in community health play. And I don't know whether that was part of your research, but it's a question there. If you don't have an answer, that's okay too. Then say you don't have an answer. But if you do, please give your answer short and succinct, please. Go ahead.
Yes, so the COD and BOD are indicators for having life in water. So the biological oxygen demand. So if it's high, therefore the demand for the oxygen is high. There are high levels of, or there are high organisms in the water. So that can also be a parameter to indicate if there's eutrophication in the waters or there's none.
Okay, I'm not quite sure that answers the question of the person asking it, unless I understood him wrongly, but we can come back to that later on. So I'm handing back to you, over to you, Dave, again.
Thanks, Lesha. And yes, let's come back to that later on as need to be. So just checking my schedule. Our next speaker is Charles Essery, who joins us from Australia, from New South Wales. He's the managing director of a company called Sustainable Water Solutions. He's going to talk to us about sustainable water cycle management. Charles, great you can join us. Hope it's not too late in the evening for you in Australia. And over to you.
Unmute. Can you hear me now?
Yeah, we can hear you.
Oh, okay, that's great. Yeah, it's not too late. It's only 7:30 in the evening, so nice chilly day in Sydney, down to about 15 degrees centigrade, which is cold for most Sydney-siders. I'm not normally from that end of the world. I was born in the UK, so hopefully you can understand my accent, and it's not Australian. Can we move past the first slide? One of the things I've spent a long time in academia and government and industry is trying to get people to actually get some balance into their approach to water cycle management. I'm fundamentally a hydrologist, therefore a very simple person. I look at water balances, but I'm also an environmental scientist and therefore very much embrace the quite old-fashioned term of triple bottom line accounting and the fact that we have the environment, society, and the economy as elements that have to be balanced. We can do it very simply, or we can do it very complexly. If you look at both sides of that diagram, that's the simple side. The complex side is what a lot of people like to do. Over many years, I would suggest that the slide in the center is the one that really is the most important one. We want to have minimal impact on the environment or zero impact. We want to actually provide a lifestyle, a social aspect that is acceptable, but it has to be economically efficient. And if we integrate those together, you can actually see that effectively all the elements of our current management of the water cycle are actually there. Water quality, public health, infrastructure, resource management, and also recreational aspects of our life. Next slide. In the approach that I suppose I've tried to adopt over the last 20 years, 30 years in Australia, it's really about trying to get people to come up with an assessment process whereby they actually understand what they want from a water project, be it a water supply, a sewage system, a dam project, and to actually look at all three aspects of how that impacts on the community outcomes that they're required: social, economic, and environment. The process we came up with was basically simply goal setting, then taking people through the process of identifying what sort of things can be done to actually achieve those goals, getting the scenarios. Then basically, before you can do anything, you've got to pay for it. So you have to do an economic evaluation. And then after that, you then start to try and build into what people want to achieve the goals that set out at the very beginning. So you're actually basically cycling through, going through the process of saying, yes, this is what we want to do, this is what we want to achieve, this is the reality, the economics of it. And then at the final stage, getting them to have a look and say, okay, economically, the cheapest one would be this. Socially, the best one would be that. Environmentally, oh, it has to be this. But you have to do the trade-offs that people require to actually say, well, it's not a perfect world, you're not going to achieve it, and then come up with the final series of scenarios that people can then choose from and actually, shall we say, put their money where their mouth is, or their vote where they want to. Can you have the next slide, please? Back in 1999, I left the water industry. Previously had been in academia, and arrived at a very fortunate spot where, rather than looking at the central Sydney, the main area of Sydney, of Australia, I actually had a chance to look at the rest of New South Wales, which is the regional country areas. So we actually set up 12 pilot projects and said, okay, how can we actually achieve the outcomes of this process? We did this and we came up with a plan. You can read the detail there in the slide. It's a bit too complicated to go through in process, but I parted away with the government in 2003 because I said a desalination plant for Sydney was the wrong way to go. So I continued on with this process of looking at all these particular projects that could actually achieve a sustainable approach to the issues they had, and they were quite varied issues. So if you go to the next slide. The process that we came up with was basically one that identified the scenarios, gave the community and stakeholders, and through what's common term as a project reference group, but they have to be open and independent groups, not quangos. And they actually came up with a scoring system that picked what was the best thing for them. Next slide. This is one that did quite a range of different things. They actually came up with a few actions. I've blanked out, redacted, I think is the common term. The names of the various things they did. But if you have a look through this slide, what they did was a series of practical things, like doing, operational things like stopping infiltration into the sewage system, but also looking at alternative things like providing security through off-river storages. And in one case, they actually said, well, let's even look at recycled water, where we pump well-treated recycled water back into an aquifer and then later on use it for drinking water purposes. This particular organization back in 2009 actually started planning for educational processes where they actually were preparing to take recycled water, drinking water quality, out to schools and demonstrating to people this stuff is safe to actually drink. Next slide, please. This is the outcomes that they came up with in their typical corporate style. But if you have a look at the detail in the slides later on, you'll see they achieved a lot of very good things. And in 2015, all those good things have actually continued on and are part of their corporate plan. And they're actually not just following through the process, they're actually incorporating it into their actual business model and their commitments and their performance criteria. The next slide. If you have a look at the other projects, I'm afraid it has not been particularly good. This is what has been achieved from some. Let's go to the next slide. But the real problem is it doesn't, can sustainable water cycle management work? It can, but there are several real problems with it. A lot of overcomplication. The water cycle is quite simple. It's difficult to manage, but it's a simple process. Regulation is one killer for it. Accountability is a real problem. Governments and regulators don't want to be accountable anymore. That's not what it was in the past. It should be in the future. Political interference is a terrible problem. With pork barreling, which is a term effectively of buying votes, and rorting is a terrible problem with professionals, and I call them bluffocrats. If those of you are fans of Yes Minister, that's a term that the authors of that particular program came up with recently. And basically we've got people in professions and bureaucracy who actually want to retain power. And we've got to actually recognize that, because they're one of the biggest hindrances to actually achieving sustainable water cycle management. We have to have transparency and independence, and it's very critical. And stakeholder and community involvement is also critical. The final thing I'd like to say on that is, when you come up with a plan, it's not just a plan, it's a living document. And unfortunately, many people do have this capacity to ask a consultant to give them the answer they want, which they're just because it's an independent result. Next slide, please. This is a quote from Winston Churchill. The further back you look, the further forward you can see. My very lame response to that is, they're very wise words, but have a look at the rest of the text. We have a lot of problems in the way you actually organize management. Now, my time is up. If you have a look at the side, that little cap on the side, this is from one of my staff. They created this thing. It's called Let's Talk Shit, basically, because we're involved in the water cycle management, cleaning the water cycle up. And if you have a look at those little characters and images, that's what you're faced with. You've got to deal with all those issues. But ultimately, you've got to actually provide people with clean water, safe services, give them access to safe drinking water, and disposing of their waste sustainably. That's all I could say.
Charles, thanks very much. I really enjoyed that, in particular your final points about the, shall we say, the human and political dimensions of all of this really chimed. It's certainly something I've learned in my career, that an awful lot of this is very human and is very political. And if we don't recognize those issues, we're always going to be struggling to achieve what we want to achieve in terms of water management and social and environmental benefits. Lesha, how are we looking on the question side of things?
Well, two of the earlier questions were answered by Diosa in writing. So if you go to the Q&A and answer it, then you can see her answer. What is interesting is that it started the discussion also with another of our participants. But I would suggest that Leona and Amat, you take that one offline, because I think that one is going to be very, very technical and maybe not good enough for the scope of this very short part of the conference. I would, however, have a question myself for Charles. I wish you had submitted your presentation to theme 5, because you're actually addressing one of the big questions. How do you get the knowledge that people acquire, that it's in such a form and shape that people can actually use it? And I thought you were referring to stakeholder community involvement, and please not politicians, okay? But maybe you want to elaborate a little bit more on what you got out of the community involvement, because the slide was not very clear. And I think it's a very important item. So over to you, Charles.
Can you hear me?
Yes, we can.
No, community involvement is essential because effectively they are the people who are the customers. A lot of water utilities. Sorry, I've got to start my video. Yep. A lot of people believe that water authorities are there to actually deliver services, but they're there to actually serve communities. They're the people who pay for it. Community involvement is very important, and if you can explain to communities what is involved, they're not stupid. A lot of engineers and a lot of scientists, and I think most of us involved in this conference are highly qualified and believe we're highly intellectual and very knowledgeable. But if you can't explain to people the basics of the decisions they have to make, then you're failing as a scientist, an engineer, even as a politician. We have to explain things in ways that the community can understand, therefore they can actually then evaluate the decisions we're asking them to make. And those decisions it might be more expensive for your rates, for the service you have to pay for. It may have an impact on your environment. It may have an impact on a range of different things. But if we can't explain to people the fundamentals of what those decisions require, then we're failing as professionals, be it scientists or engineers.
Okay. I think your crucial word is explain, and that we have to learn how to do that and get information to the people that have to make decisions on their own lives. But Charles, you'll get another chance later on. So I'm going to hand back to Dave for our next speaker. Thank you, Charles.
Thanks, both of you. It's a really interesting discussion, and I see sort of further thoughts are popping into the Q&A box around it. So that's definitely something we might want to revisit at the end of the session. But let's move on for now. We're gonna go to China next, and first of all, hear from Yan Yang, who worked for IWRA, the General Institute of Water Resources and Hydropower Planning and Design, which is one of the main, well, I call it one of the main think tanks in the Chinese Ministry of Water. Yan Yang is going to talk to us about groundwater issues, and I know from some work I've done with GIWP in China that there are some profound challenges, but also some really innovative thinking happening in China on how to address groundwater management challenges. So, Yan Yang, over to you.
Okay, thank you. Hello, everyone. Today, I will give a presentation titled Strategy of Groundwater Exploitation and Utilization Based on the Groundwater Functions in China. Next slide, please. Next slide, please. Yeah. This study is a summary of the concerns arising from the definition, classification methods, status evaluation, and management measures of groundwater function zoning based on our big work of national groundwater function zoning in China from 2003 to 2013. I will use 3 parts to present our work on groundwater function zones. The first part is the methodology of groundwater functions. Next slide, please. I think that the term of groundwater functions is closely connected to the interaction with other natural circles, and humans' activities. From the relationship between groundwater and other natural system and social system, 4 main functions of groundwater can be found. The first is the function of circulation and reserve. Groundwater is an integral part of water cycle. It maintains the stability of the whole water system through its enormous circulation and reserve space. The second function is the maintenance ecology. As we all know that the groundwater is the decisive factor for many ecological systems. It plays a role in the water quantity balance, the water salt balance, the water heat balance for many ecological environments, and regulates the ecological hydrology. In some places, it is a key factor to maintain the surface vegetation, lakes, wetlands, and other ecosystems. Next slide, please. The third function is that groundwater is an important and particularly active geological agent. And the groundwater system plays a supporting and protecting role in the stability of geological environment. Groundwater overexploitation may cause geological and environmental disasters, such as the seawater intrusion, land subsidence, land fissures. The fourth function is the water supply. In some places, groundwater is even the only water source, so its importance is very significant. Next slide, please. Based on the classification of groundwater functions, we use our 2-level system to represent those functions. The primary level is composed of 3 types of zones, which are the protection zone, exploitation zone, and the reserve zone. Then the 3 categories are further divided into 8 secondary function zones. It should be noted that the definition of groundwater function for one specific unit is only determined by its main function, and the identification of the main function of a certain unit is also an important work in this study. If we apply this classification to the whole territory of China, we can get zoning of the groundwater. Let's see the next slide. Next slide. Let's look at the distribution map of the primary groundwater functional zones in China. The vast area is occupied by the color blue, which is the protection zone. You can notice that most of them are located in the mountain area. The orange color is the exploitation zone, which is mainly the plain area and where human activities are very frequent and intensive. The green area is a reserve zone where the groundwater is almost kept unused. The primary level zones mainly reflect the interaction between the water use for economic and social development and the ecological and environmental protection. Next slide, please. Total number of 4,886 secondary function zones. Function zones is identified for the shallow water groundwater. These zones are almost across China, which are the first type is the central water supply zone. These are usually the high intensive groundwater pumping sites in the urban areas. The second type is the distributed exploitation zone, which usually refers to the low intensive groundwater use, usually in the rural area. A third type is emergency water supply zone. It has relative good conditions for groundwater reserve, exploitation, and water quality, but it is usually prohibited for exploitation because water supply is provided only when emergencies or extreme droughts occurs. The fourth type is the water reserve zone. It has the very good recharge and storage conditions, but there are few human activities at present. In some water reserve zones, the local surface water can meet the water demands, and there's no or only small scale of groundwater exploitation. Next type is the groundwater conservation zone. It is where groundwater exploitation in human activities are constrained in order to keep the water cycle healthy and stable. The zone is mainly located in hilly areas, springs, rivers with important ecological significance, and riverside areas are also categorized as groundwater conservation zones. The next zone is the ecological fragile zone. This type of zones usually applies where the groundwater has great importance of ecological conservation, and the ecological system is very sensitive to the groundwater change. Example includes wetlands, natural oases, and their surrounding areas in arid or semi-arid region. Next is the geological and environmentally sensitive zone. This zone is found where a decrease in groundwater table would result in seawater or salt water intrusion, land subsidence, groundwater pollution, and many other disasters. The last type of zones is the unsuitable exploitation zone. It is where the poor water quality and the poor groundwater exploitation conditions, which cannot support the pumping of the water users. Next slide, please. Next, I want to introduce the management and the control based on the groundwater functional zones. Based on the classification and the definition of each unit's groundwater functions, we've also formulated for each unit control indicators, which includes the groundwater exploitation and the water table. For the control indicators of groundwater exploitation, it means we need to find the proper pumping rate for each unit so that no problem could occur. There are three principles. The first is the stabilizing the balance of groundwater recharge and discharge, maintaining the healthy water cycle. The second is meeting the water demand for the natural environment and retaining sufficient strategic reserves. The third is making the groundwater use efficient. So next we have the corresponding measures. Next slide, please. For any groundwater function zones that already have problems with groundwater overexploitation, and new groundwater use should be prohibited. Some actions are also launched to alleviate the overexploitation. For any groundwater functional zones that are near overexploitation, no additional new groundwater use will be permitted in the future. Next. Under the above two situations, the control indicator for these zones should decrease or strictly stay unchanged in the future. We have also made three measures for the exploitation zone, protection zone, and the reserve zone, respectively. And finally, we also have our conditional actor indicator for the water table, which are composed of the maximum and the minimum depths. So these are also very effective tools for us to implement of the groundwater management. Thank you. Thank you.
Yang, thank you for that. It's an impressive piece of work, very large scale zoning exercise in China, and I'm aware just how much energy and effort has been put into it. So thanks for giving us a brief overview. Time is a little bit short, but Lesha, are there any questions coming into the chat box that we should address now?
Well, there's one question again aimed at Yang, but maybe you would like to go to the Q&A box yourself and maybe see if you can give a written answer to Mr. I think it's Mr. Ahmad Majar.
Yes. Okay. Okay, I will answer in the Q&A box. Thank you.
Okay, very good. Thanks. Back to you, Dave.
Okay, thanks, much appreciated. I like this Q&A box facility. It's very useful, actually. Let's stay in China, and this time we're going to hear from one of Yan Yang's colleagues in GIWP, Ding Wang. And Ding Wang is going to talk to us about a good water management system for human development and ecosystem sustainability, which sounds squarely on message for this sub-thing. So I'm looking forward to hearing this. Ding Wang, over to you.
Okay, thank you, Dave. My name is Ding. Hello, everyone. Today I will give this presentation on behalf of Dr. Zhao. He's in the other meeting. So I would like to share our thoughts of what a good water resources management system is like to fulfill the requirements of both humans and nature. Next slide, please. So we think a good water management system should have goals equivalent to water security. For water security, we know that we will expect some situation we will achieve to have good, acceptable water quality to sustain our livelihoods and social and economic development. And we need to have good water quality to prevent waterborne diseases and pollution. On the other hand, we need good water quality and quantity to support the ecosystems. The water security actually echoes the SDG 6, which is the Sustainable Development Goal 6 set up by the United Nations. To achieve water security, we need to find a water use balance between humans and nature. In terms of the hydrologic cycle, there are 4 key elements in a water system. That is the quantity of water, the quality of water, the timing of the flows, and the water space associated with the riparian space. So we think to reach water use balance, we need to reach a balance for each element. Next slide, please. So for water, for human activities, we usually have negative effect on water resources. On the other hand, the water resources have maximum capacity to support human activities. The maximum capacity we can describe as the carrying capacity. So we need to make sure the human impact we give the environment is lower than the carrying capacity. So the general approach is to reduce human impact as well as to increase water resources carrying capacity. To have a good water management system, we need to have a good supportive environment. This includes an effective legal system, well-structured institutional setting, and appropriate management institution, the instruments, as well as the functioning water infrastructure. Next, please. So here, let's imagine we are the consultant to help the government to build a water resources management system. First of all, we need to understand the background information of all the factors related to water. For example, we need to understand the climate, the geography of the specific location, its ecological and environmental conditions, the social and economic status, and we also need to understand our ability to regulate or control the flows, et cetera, et cetera. So we also need to bear the balance of human impact and carrying capacity in mind. This will become some specific objectives for each element of that hydrologic cycle. For example, we need to make sure acceptable water quantity for both humans and the environment. We need to make sure the pollutants and the nutrients we discharge to the environment is lower than the maximum level of the environment can be deal with the contaminants. And we also need to make sure sustainable timing of flow regimes. For the we need to manage water and riparian space together for ecosystems. After we achieve all the objectives, we think we will obtain the goal to have the balanced water use for humans and nature. Next, please. So now I will discuss what we can do for each element. This is for water quantity. We demand water from the environment and the environment supplies the water. So there should be a balance between the demand and supply. If the demand is higher than the supply, there will be a gap. So how to deal with this problem? We can reduce and control water demand or increase water availability and water supply capacity. So here I just list some typical measures for reducing the water demand. We can control the maximum water use through laws and regulations. We can, when we plan the social and economic development, we should consider water as a constraint. Actually, it's an important constraint. And we need to promote water saving and enhance water use efficiency. And we also can implement water pricing policy to regulate, to control the water use behavior. To increase water availability, we can optimize water allocation, divert water from water-rich areas to scarce areas. We can enhance water storage capacity, encourage people to use non-conventional water, and promote water recycle and reuse. Next, please. For water quality, we know that we discharge pollutants and nutrients to the river system, and the contaminants flow through the river, and they will diffuse and degrade. So to control the water pollution, we need to decrease the discharge and increase the ability of the environment to handle with the contaminants. So this means we need to control the pollutant discharging through some strict laws and regulations. For agricultural production, we need to control the nutrient input. For industrial sector, we need to adopt cleaner production. And for stormwater, we need to manage stormwater runoff. For municipal wastewater, we need to improve wastewater treatment capacity. And we also need to reconnect the freshwater system. We can build some wetland alongside the river to increase the ability of the environment to degrade contaminants. Next, please. So for the natural water river system, the discharge varies with the time. We also have some high flow events. This is important. It's usually from the floods. They have ecological importance. So we need to, ideally, we need to control to achieve the good flow regime, which is natural flow regime because of time. So this I just list some important measures we can follow. So next, please. So in addition to water space, we also need to manage the riparian space, because they are important for the environment and ecosystem. And this means we need to manage both water space and riparian space. For example, we can control the erosion and siltation to restrict land use change and to rehabilitate the riparian zones, restore the river system. And this picture shows a river restoration example carried out at the Yongding River in Beijing, China. Next, please. So for good water resources management, we need to zoom out to have a bigger picture, because water resources actually related to a lot of different sectors and factors. So we need to think about all of them. And the other thing is we cannot focus on just a very specific location. We need to think about the whole basin as the whole scale for integrated management. That's it. Thank you.
Ding, thanks very much. That was absolutely perfect timing. You definitely win the prize for using your allotted time to the second. Very impressive. Equally impressive is, I think, what you've outlined, the evolution of thinking over the last 20 years about how China should manage its water resources. I think it's been pretty remarkable. And I think you've given a really good flavor of that in a very short space of time. I guess the challenge now is all about implementing that thinking, and I know that's something that GIWP and others are putting a lot of work into. Lesha, questions in our chat box, or any questions you might have?
Well, I think there's the same question to our two previous speakers, to Ying Yang and to Ding Wang. And both have to do with balancing the availability of water, the growing urbanization, and how would your research help in getting a better balance between what's available, regardless the quality, and what is asked by people for their daily use. Ding Wang, I give you the floor first. What would your comment be?
So in terms of China, you know, we have a high population, and our water resources is actually limited. So this is a big challenge to manage how much water we can use and how much water we need to give the environment. So there are also a lot of competition between them, and also different provinces in China have different water available. So we have a lot of regulations and policies, and we also carried out a lot of research on this issue. So recently, our government promotes to implement the environmental flow. This, I think, is a very useful tool to make sure the environment has enough water left for it. And the other thing is we are promoting the water pricing mechanism, and hopefully it can be used between different provinces, because some provinces have like the higher water demand, they have a stronger economy situation, but they have shorts of water. But some other province, they usually mainly doing some agricultural activities, and but they have a lot of water, so they can have some extra water to actually sell to the other, other provinces who need more water. So I would say like both environmental flows, policy, and water pricing are helpful in China.
Very interesting. You almost sound like somebody from another continent. But let's see how successful that's going to be. Yang, what one quick reaction to this question or to what Ding Wang just said? You have to unmute yourself, my dear.
Oh,
Yes.
sorry, I just spent my time on the Q&A box. Sorry. I just answered the questions. Sorry. I didn't.
No, which is really good. No problem. If you think you've answered it already in the box, then
Okay.
I'll guide everybody to have a look at the Q&A box, and then there is a tab on the top that says answered, and you can see the reactions from our speakers to some of the questions there.
Yes.
Okay, thanks, Yin Yang. Then I'm going back to Dave.
Thank you too.
Thanks, Lesha, and everybody. So back to Australia, back to Charles Essery for his second presentation, which I think is going to revisit the theme of the first one on sustainable water cycle management, but particularly look at the concept of net zero discharge. So Charles, back to you.
I've muted myself. Is that okay?
Yeah, we can hear you.
Oh, that's great. Okay. Look, similar topic, but from a different angle. What I would ask you to do is have a look before going away from this slide to the two slides or images. The one on the right-hand side is a traditional water cycle that we all know about. But when I gave this to Sydney Water, when I joined them in 1992, they saw nothing below ground. All they saw was infrastructure. The one on the left is actually the Mir space station. Just hold that in your mind as we go through this talk. Next slide. Triple bottom line, basically, yes. I'm a strong believer in this three-dimensional concept rather than the multi-dimensional concepts that people have. They have four-sided octagonal dimensions, but basically environment, society, and economy are the three things we have to actually deal with. If you have a look at some of the issues we have with water, it can be fully recycled to potable level quality. The problem is politics, health, environmental agendas. Solids can be used for landscape uses. They get rid of impurities. Most of the time, but some people actually, or organic movement seems to say, oh, there are impurities in the solids, the bar solids we actually put on land. Dissolved salts, we can reuse them. They're viewed as a waste stream, but they are actually a valuable resource. Minerals, the same. Grease and oils, exactly the same. They're seen as a waste stream, but they're actually a beneficial thing. Biogas, now actually starting to be seen as something that has been used for 30 years to help generate energy within wastewater treatment plants. But we should be using it from all of our facilities to actually generate gas. Energy recovery is the one that is a bit of a problem. We have to look at that and look at heat pumps and ways of maximizing the extraction of energy from what are very chemically and biologically active waste stream processes. Next slide. The greatest misconception I've come across in my 30 years in particular wastewater is that people treat water as the issue, and it's not. 99% of the wastewater we have is actually just water. Water is the means of transporting our waste away from where we don't want to see it to somewhere we can't see it. That's what a wastewater treatment plant's about. Water is not the issue, it's the contaminants that we're actually trying to get rid of. But we then should think about recycling. Most of our major cities around the world basically use receiving waters, that's rivers, lakes, estuaries, oceans, as dumping grounds. Ultimately, when it comes to net zero discharge, it's all very much about CO2 these days, but in reality, the most important issue is about the resources we use, and energy and carbon dioxide is only one of them. I would try and define it as an opportunity to finely tune existing technologies and regulations to add dimensions of full life cycle cost and triple bottom line evaluation, accounting, and performance. Next slide. On the right-hand side, you've got the traditional approach. It's basically what I call suck in and spit out. You take the water in from traditional sources, you run it through the system, and you dump it. And occasionally on the side, if you're very good, you do some recycling of the waste, biosolids, and demand management to try and reduce your consumption. But in reality, what we should be doing is taking all the inputs we have on the right-hand side, taking them through, and if you have a look at that middle box, the water use side of it, we have to start managing that cycle. So we take the stuff in at the top, we manage the human side of it internally within our cities and villages, and we minimize the impact out. Next slide. There are lots of tools available: life cycle management, effluent return flows, low-based licensing, drinking water standards, water rights, licensing and trade. Water is now literally becoming effectively one of the, it's a virtual Bitcoin. It's a big business. And then we have natural resource management. And one of these things I hate, if you have a look at that right-hand bottom or left-hand bottom side, one of these word map things, natural resource management, biodiversity, ecosystems. These tools are all very valuable, but we have to actually use them together to get net zero discharge of waste, not energy, not CO2. Next slide. That environment, society, economy. Next slide. If you look at the technologies we have around, this is not rocket science. Biodigesters. I did my PhD with someone who spent his life on biodigesters. Water sensitive urban design, rainwater harvesting and treatment, particularly treatment. We all see rainwater as, oh, well, that's that dirty water comes off the roof. If you treat the stuff, which I do in my own house, I use it for everything in the house, including drinking, because I treat it properly. Biosolids, we can use biosolids. We can also extract the salt. We all know about biosolids, but we don't actually think about the saline component of the wastewater. Sewer mining should be done. Decentralizing of our water and sewage treatment plants, that is essential. On top of that, of course, we have advanced water treatment processes. Everyone's very accepting of desalination, but they don't accept recycled water from effluent, which is just as clean, but takes far less energy to produce. Next slide. Next slide. Sorry, that's just the. In New South Wales, we have a thing called a return flow effluent credit scheme that was established in 2004, but it's never been used. It basically says, fundamentally, and you can look at this diagram afterwards, that if you actually extract water from a river, use it, treat it, give it to your community, and then treat it again as wastewater and put it back into the river at a quality better than, equal to or better than what you took it in from, then you didn't use the water. Therefore, your water license does not have that extracted from you. In other words, you gain that flow because you've treated it back to the level or even better than it was before. So you don't lose access to that tradable water license. Next slide. Next slide. Nope. Nope. Oh, no. If you have a look at what I have here, this is Sydney, our biggest city. And this is what we currently do. I'm a hydrologist by training and background. Those little white blocks are two basically water balances. And you can have a look at the detail of those and see before and after. Currently, what we have is three basic large drains which discharge primary treated discharge into the oceans, which is good. It's fine, doesn't have any problems because it's a very big water environment and very active. But if you're actually doing water cycle management properly, you would actually do decentralized systems where you actually recycle the water properly several times over. That's how you get a sustainable water cycle. That's how you get drought proofed. That's how you get resilient water supplies, irrespective of the variability of climate. If you're recycling your water several times over, you don't have a water shortage, and we don't have that in Sydney. There's more water in Sydney coming from the skies, actually 50% more than where I come from, Belfast, than we need. Well, we just don't manage it very well. Next slide. Next slide, nope. This is the classic example. I remember talking to a parliamentary inquiry, and it was in Canberra, the top end of town, our capital city. Ultimately, the water that goes down the toilet from there is treated and goes all the way down a river to a place called Adelaide, 40 days away. That's the bottom end of the river, the very Darling Basin. That's basically toilet to tap recycling, because every town in between in this map sucks it in, spits it out, and gives it to the next person down. So a parliamentarian sitting in Canberra, 40 days later, he'll actually be drinking his own shit, as I would say. Next slide. It can deliver. You can do net zero discharge. The important thing is, can we actually get the community and the stakeholders to get past the problem? One thing I would say is we have to make sure we don't allow a water system to be, or the credibility of water recycling to be as fake as some of the stuff is in the carbon offsets and trading schemes. Next slide. The thing I would add at the end of this is, you've seen this slide before if you've watched the last one. Have a look at that little space station there, the Mirror space station. That is total water recycling, sustainable water recycling. The Russians were given $700 million for the technology to allow that to be used in the International Space Station, because they actually manage water recycling properly. They've managed the water cycle. It's about time we do the same too. And as my colleagues, former staff said, let's talk shit. Stop all this bullshit and realize that recycling is natural. It's not an unhealthy thing. Net zero discharge. That's what we need.
Giles, thanks again. Thought-provoking stuff. And while I'm not a water quality expert or a wastewater treatment expert, I think this idea of net zero discharge chimes with a lot of things I have heard about circular economy and about treating waste, not just wastewater, but waste generally, as a valuable resource that can be used to support all sorts of socioeconomic objectives. I'm sure there's lots of devil in the detail about that, but it's definitely something we need to think about more. Now, Lesha, I'd be grateful if you could do two things around the Q&A here. First, if there are any specific questions for Charles on the basis of what he's just presented. But then also, I think we have a few minutes. We have about 10, 12 minutes for a broader Q&A session reflecting on everything that we've heard from all the speakers. If you could marshal us through that, that would be brilliant.
I'll do my best. I think there are probably two questions that were more or less addressed to Charles Essery. One is a question about people accepting recycled water. So not being scared of using it, or being reluctant. I remember a huge debate in Australia about recycled water, which in the end actually led to signing off, not going further with a huge project on recycled water. I think it was in Perth, but I'm not completely sure anymore. I think the second question that came up a few times is your comments on legislation. So you made a few remarks on, okay, but legislation is actually stopping us of doing stuff that we could do well, but it's not up to date. And I think the third one was on your comment on biogas and wastewater. So maybe you can try and address those three questions actually. Short and concise.
A community consultation is one of the key things, and one of the problems we have is the lack of clear information to the community. There are a lot of vested interests who seem to not want to explain the water cycle to people. I use that second last slide as when a very senior person on a committee would say, oh, we're at the top end of the catchment. And I said, well, 40 days down the track, you're going to be drinking your own sewage because that's where your water came from in Adelaide at the bottom of the catchment. We don't explain to people the water cycle properly. We don't explain to them the fact that a lot of the water we drink is actually of a lower quality than recycled water would be in the first place. A lot of our water is untreated. I mean, we're in the Western world, we are actually, I think we're blasé. We just treat the water we have as pristine water that comes out of the tap, yet we don't know where it came from. And it's actually about education of where the water comes from and how lucky we are to have in the Western world very good quality water. And this myth about recycled water being bad for you and not being properly treated. And I'll take you on to the second thing, the regulation side of things. We actually have recycled water guidelines that originally came from the WHO and are in Australia that are far more stringent than the drinking water guidelines for ordinary water supplies. So why do we actually do that? The drinking water we have does not have to be tested as heavily as recycled water, because guess what? The recycled water is better quality than the water that we actually get from our normal catchments. Hello?
Yeah, I'll try again. Isn't it so, Charles, that we didn't incorporate new technology, new knowledge into our current legislation? So people have been told, poop is dangerous, urine is dangerous, don't touch it, stay away from it. And we put that into our legislation a long time ago. I mean, mainly in the 1950s and 60s.
Yes, but our legislation is there to provide basic standards. Unfortunately, what we have done is we actually do have a risk-averse development of guidelines. They're not regulations, they're guidelines that actually dominate how we think about water. And when I wander around, I live in Australia now, and I'm very proud in the state of New South Wales that 96% of people have access to basic drinking water and basic sewage services. But I look around the rest of the world and we don't have access to that. And yet we sit around and complain to the nth degree about the problems of recycled water. And yet we are totally in ignorance of the lack of access to decent water and sewage service that people have in the rest of the world. Therefore, we're basically wasting our time.
Well, I think Charles, you made your point, and that's some of the insights that you gave and some of your colleagues also could help to maybe redirect that debate and see where it leads us in the near future. Yin Yang, I saw you listening very, very carefully. Would you like to make a general comment on what you have heard? What was new things, new stuff for you?
Yes, it's very today's representations are very informative for me, and as you may not know that my work is usually focused on very general and very large problems occurs in our country, usually the water-related problems in our country. But in today's presentation, I noticed that the scientists from Philippines and Australia's give us very inspiring ideas in water management. So it is a very good help for me, and I will try to find some chances to make some further study on their topic. Thank you.
Okay. Diosa, there were two questions to you at the beginning of our session. And I thought maybe you want to come back to that as well, because they were pretty technical, but on the same, I think they were also on the same topic, like how do people understand where they can use or not use certain water, or where it's important to make a distinction between the elements that are in the water. Would you like to come back to that?
Yes. In our study, we only tested 3 parameters. So in our standards, we have at least 7 parameters that the water needs to pass so that it can be potable. So with the question of can the water be reused for us for at home or for drinking or for cooking food, I think it must be first tested for other parameters. And then in terms of the COD and BOD, I think we agreed on the we agreed that when the BOD is high, the oxygen may not be enough for the aquatic animals in water, so they may not survive in that area where the BOD and COD are high.
Okay. Dave, you are an expert on environmental flows, and you know a lot about it. I think it's one of your main topics. And I heard Ding Wang say a few things about that. So you want to either respond to him or answer or put your own question?
Yeah, so it's very interesting that China is really beginning to look at environmental flows as potentially a key element of water management planning regimes. And I've had conversations with Ding and with Dr. Zhao about what that might involve and how to go about it. Of course, the world is still learning about environmental flows, and in particular, not so much about how to define environmental flows. There's an awful lot of good science that's happened over the last 20 years on how you can, or different techniques for defining environmental flows, taking account of a variety of characteristics. I think the world is still learning how to actually go about implementing those flows. And so for me, the interesting thing, and I'm interested in Ding's view on this, but also perhaps Charles's view, because Australia has been at the forefront of the environmental flow challenge. The interesting question for me is around implementation, and in particular, what we've learned about how to embed environmental flow implementation into broader water planning regimes. And both Ding and Charles have talked about that. So I'd just be interested in any reflections about that implementation challenge within broader water resource planning regimes.
Do you want to respond to that? Ding Wan, hello?
Okay, maybe I answer first.
Yes, please.
Can you
Yes,
listen?
we can hear you perfectly.
Okay, that's good. So I think environmental flow, what I learned is we can set a higher level of requirements or a lower level of requirement. It depends on the trade-off, between the human society, economy, and other human activities. So for some water scarce regions, maybe we can set a lower requirement level, and it will be easier to be implemented. But for some place, actually more naturally, we can set a higher level of requirement. This should be help us to implement our policy more easier. And after we achieve the lower level, and we can increase the level gradually to ideal position. I think that is what I think about how we implement our water environment policy. Because in China, we do not have such policy before. So it has a lot of competition and discussion about how to implement this this environmental flow. Because before, some regions just thinking that we should use all of the water, and that is not, environmental friendly. So we have to start start this regulation little by little, and increasing the level of our requirements.
Okay.
Yeah.
Well, I think this conversation just started. Having said that, I think we're at our time, because we still need to do a few housekeeping announcements and other important stuff. So from my side, thank you all very much. I think we managed in answering most of your questions. If not, they have been recorded, and we'll try and get back to you. And thank you very much for your inputs, both the panelists and the participants on the Q&A. And with that, I give back to Dave.
Thanks, Lesha, and thanks everybody on the panel. As Lesha says, we could have carried on talking about this stuff for a long time, but our time is short. It's normally the task, the fool's errand, if you like, for the moderator to try and summarize a session. That's always remarkably difficult to do with such a wide range of perspectives that we've heard. Personally, I found it very interesting, really interesting actually. And we do seem to have addressed a few sort of themes. So around water quality, we've looked at emerging technologies, but also a shift in concept for wastewater, shift in philosophy, if you like, around treating it as a resource and aiming for net zero. We've gone to the complete other end of the scale and looked at sort of national planning for groundwater zonation in a very large country like China. We've had a couple of presentations which have looked at the really important role of water resource planning in one way or another. And what's been interesting for me in both of those presentations has been a real emphasis on what Charles called the triple bottom line, what Ding sort of reminded us about, which is the perhaps forgotten role in environmental sustainability, and the need to pay greater attention to that as we move forward. And I guess we've also heard that whilst, of course, there are really important technical dimensions to this, there are also some absolutely critical human and political dimensions that we all need to remember. Lots more I could say, but time really is up. So it just remains for me to say thank you, Lesha said, all the panelists, and also to everybody for sitting in on this. I think we've had a great turnout, really good set of questions and interaction in the chat box. So thanks to everybody for that. It just falls to me to say thanks again to IWRA for organising this. And I think I'm meant to hand back to somebody, possibly some Phil from the IWRA team, who just wants a couple of housekeeping announcements. So thanks again.